Welcome to a brief demonstration of how to read computer printout. What I have here is some data which is actually kind of hidden because you don't have the actual data, but I have the printout of data that you've worked with. In fact, I believe you worked with this data yesterday. It's the data that showed distance a plane travels versus its fare. Well, as you can see right here on the x-axis we have distance and on the y we have fare. What I want to point out is that a lot of times on the AP exam they really don't want you inputting data into your calculator because you could make that typo. So they're smart. They give you data that's already been analyzed in a computer printout and they want you to read it. This is just one example of computer printout. It's very, very generic. The types they use change, but they all have certain features in common. This one is really nice. It tells you the dependent variable is fare, which means fare is on the y-axis. It tells you r squared, and it also tells you the adjusted r squared. That's something you don't need in this class. It tells you the standard deviation of the residuals, which is the average distance from each point to the line. And it also tells you something called degrees of freedom, which we'll talk about more during the year. Now, there's a lot of extra stuff in this computer printout. For example, all of the stuff about the sum of the squares, you really don't need to know. If you're lucky, the computer printout they give you will just have this box. When you look at this box, there's a lot of stuff you don't know, but you will by the end of AP Stats. What you need to focus on are two things. You need to focus in on the constant and the number below it. The constant is always the y-intercept, which we've been calling b sub 0. The number beneath it is always the slope, which we've been calling b1. That's how it'll always work. In fact, I always think that the slope, b1, is right next to the variable that's next to it in the equation. So that means the distance is on the x-axis. If you look at the questions here, it says, is the linear model appropriate for estimating the fare? Looking at this residual plot, we see a nice random pattern. So we'd say, hey, yeah, this is appropriate. Yes, because the residuals are random. How strong is the model? Well, you would look at your r squared, and our r squared is only about 48.2%. So we would say not very, and we'd finish up by saying r squared is low. But there's more that we'd have to say. We should continue with about 48%, and I'm going to just say the next part, of the variation in y, which is fare, is explained by variation in distance. And this is low, so it would be bad for prediction. Looking at this graph, it also asks you, are there outliers? And we really can't say much about outliers at this point, but we're going to go right now to number 4, which says, what's the equation of this model? Now, we already said that we are predicting distance. Actually, we're predicting, I'm going back a second, fare. So fare is on the y-axis. So with that said, I'm going to go predicted fare equals the y-intercept, which we saw up here was 177.215. So I'll just call that 177.2 plus the slope, which is we're going to call 0.079 times the x, which is distance. And that's our equation. As you can see, we got that right off of the computer printout. Again, the y-intercept was way up here, is the constant, and underneath it is the slope. Now, if I wanted to make a prediction, I could go ahead for, say, a 1,000-mile flight. I could plug in 1,000 and then make my prediction, which if you do this would turn out to be 255.83 or $255.83. Sorry that my writing looks kind of like a maniac, but I really wanted you just to see some examples of computer printout. Here is another example of computer printout. This one is much prettier. It's from a program called JMP, which I'm going to teach you how to use. It's looking at knee circumference to predict thigh circumference. Kind of silly. You can see looking at this that it's a fairly strong linear association. If we continue along with this, this computer printout shows me a lot of extra things. But what I want you to focus on, again, is this box right over here. This time, instead of saying constant, it says intercept. So right here, that's our intercept, and below it is the slope. So if we wanted to predict, thigh circumference, it would equal the intercept, which is negative 7.7, plus the slope, which is 1.74, times the knee circumference. It's really that simple, the computer printout. Now, below this, I've shown a picture of the residual plot for you to take a look at. And this residual plot shows a very random pattern, so you would feel pretty good about using the linear model for it. This is a brief summary, and hopefully now you'll be able to do some problems where you're going to work with computer printout and answer some questions. Hope this helps.